So if we come through here, we're going to go through the script from the bottom up, which is really the best way you want to design your scripts. You want to think about all the little functions that have to happen, and then it becomes kind of like Legos. You have all these individual little bricks, and then you kind of stack them up, and by the time everything's done, you have this nice big thing built. There's going to be sections in the script that deal with things that we're going to cover in the next couple of videos. So there's going to be a couple of times I'm going to say ignore this for now, so just kind of go with it. I try to comment things up as well as possible so you can follow along. And I've broken it all down in sections so that way you can concentrate on certain areas as you're reading through the scripts. First thing you're going to see here is this global int. Ignore this for now. We'll talk about it at the end of this video, just to know that this global int is basically going to float around in our global space, and we will deal with that in a bit. So this first section is really some low level local procs that are basically just going to do some minor tasks for us. This one here is going to return IK handles for a given pole vector control. And basically what it does is it takes the control, it looks for the pole vector constraint, and then it looks for the IK handle plugged into that pole vector constraint. This is a function that basically just locks the translates on a given object. This one will lock the rotation. And this one will lock the scale. Now why don't we just run setAtter every time? Well, for one, if I just ran setAtter and let's just say for example we just plug these commands in instead of calling this. So instead of having one line of code, we now have 3 lines of code. That's problem number 1. Problem number 2 is this actually does some error checking. It looks to see if it's already locked, because if you try to lock something that's already locked, Maya will object. So let's say for example you actually put this in all your code. You actually are locking them one by one. And then you say, oh, I didn't check to see if it was locked first. Now you have to go back to every place that you've put that code in and put in the error check. This way, if there's a bug with the way you set up how you're locking your scale, you only have to fix it once. That's right here. So all the other functions are going to just call this. And so if there's a bug in it, you only have to fix it once. So they're stupid simple procs. There's nothing really complicated here. All this really does is save you typing 6 times 3, 18 lines of code becomes 3 lines of code. And it encapsulates a very redundant function, so that way if there's a bug in it, you can just fix it once and then you're good. These two functions, copy translation, copy rotation, again, they're not big procs, they're only a couple lines. Why do we even bother? Well, one, it takes 4 lines of code, makes it 2 lines of code, which is always a little bit better. Not a huge savings, but regardless. But more importantly, let's say your call to Xform, you discover that you're calling it wrong, that you weren't calling it from the world space. That's what the WS stands for, world space, query, world space, translate. Let's say that, oh, world space doesn't work, it has to be absolute, or I was calling it locally when it's supposed to be world space. And so every place that you got that line of code, you got to make sure that you fix it. With this, if there's a bug in it, again, you're just fixing it right here and then you're done. So getting used, even stupid simple stuff like this, if you're doing it a lot and repeatedly, encapsulate it into a simple proc like this, and it will save you some pain and effort along the way. This second section has to do with procs that we talked about in the last chapter or last video, to automate the setting up of the IKFK switching. So I've already gone through this pretty much, so I won't talk about it too much. That just adds to the attribute for the pole vector marker, for the IK switch marker. This sets up a pole vector marker for you automatically. This hooks up the entire pole vector marker, locks it off the whole 9 yards. So, and this does the same thing for the IK control marker. So we talked about that last chapter, so you can go back and review it there. So now we're actually going to get to the IKFK switch prox. Now the first half of this section are low-level local prox. Now, important thing to note is that local prox have got to be written before they're actually used. For example, if I got something like this, proc A, and then proc B, if proc A is actually trying to call B, this won't work because it's read from top down. So B has got to be first. That's one reason why some people tend to make everything global, because global procs don't have that problem. You can put them anywhere. Local procs, they have to be declared before they're actually used. So this wouldn't work. This would. So, and you'll notice that we got local procs down here and we have local procs up here. That's all fine. It doesn't matter where they are as long as they're declared and written down before you have to use them. That's the only caveat. So this one here is going to zero out custom adders. What that basically does is, say you have a foot control. Our foot controls have all these different adders for the little sliders for the pivots, you know, so it can move the toe around, it moves the heel. It's got that little auto rock kind of thing going on there. This basically goes through and anything that was custom. The -UD stands for user defined, and the -K stands for keyable. So any custom stuff that we put in, it is going to zero it out. And you'll notice it's got a couple of exceptions here. I'm not going to talk about local to global here, but in the next chapter we will talk about IK wrist, and we'll get into that in the next chapter. This one I don't even think we used, to be honest. Update IK driver values. Takes in the IK control, and actually this is, we're not going to cover this right now. This has to do with some of the advanced rigs that we're going to talk about in the last video. So we're going to skip this one for now. We'll come back to this. Get FK control rotations. Remember what I said about what the IKFK has to do. That when we're switching from IK to FK, it's got to record these rotations, turn the IK off, and then reset these rotations. Why? Because if they have an incoming animation curve and you just turn it off, then I can illustrate that real quick. Let's just kind of pose it. Okay, so there and there. So if we turn this on, it's going to pull it back out. So if I turn it off, it's not going to stay frozen here. It is going to zip back here. So what we need to do is we need to record these rotations, turn the IK blend off, and then set those rotations back. Okay. Just going to refresh that. So this is what this is going to do here. This is going to just to get the rotations for the controls. And then it's just got an array, and every 3 entries in the array is going to be one set of rotations. So as you can see here, it's actually adding them. This would be 0, 1, 2, and then I actually gets incremented in increments of 3. So the next time it goes through the loop, it's going to be 3, 4, 5, 6, 7, 8, and so on. And then it's going to just return that array of rotations. So this is what's going to get called before we turn the IK off. This is the reset FK rotations. It's going to take a list of controllers and it's going to take a list of those rotations that we have set. And then for each one, it's going to say, okay, there's your rotate X, your rotate Y, your rotate Z, and set it. So this is what's being called after we turn the IK blend off. This proc will return IK handles for the given object. The object this is for when you're switching from FK to IK, because it will at this point here it's looking for effectors, and it will list all children looking for an end effector, and from there it's going to look for the connection for the IK handle. So that way the switch will happen in any one of the FK joints that we select. Return IK controls. As you remember, like in this example, the IK handle is actually a child of this controller, and this would be an example of like if we had a foot where we have a lot of complex rolls and pivot points set up, and we're not actually manipulating a single IK handle, we're actually manipulating a control that has nested IK handles in it. And given the list of IK handles, it's going to go through and look for anything that's connected to that IK blend. And as you remember, we kept that as a convention that IK controllers are going to have the IK blend in it as well. And for a given IK handle, it will return the control. And if it doesn't have a control, it's just going to return itself. Return FK controls. For a given IK controller, it'll find the IK handle, then it will find the start joint, because the start joint is going to be connected to the IK handle. From then we're going to list all the joints that are a child of that IK system. And notice it will do everything, because when I create a control rig, I build the sections I need. If this was an arm with hands and fingers, it would actually select the whole thing. So I've never had to, I've never needed it, but if you were using it on something that had children underneath this, you could modify the script to say, hey, stop when you hit the end effector joint, don't go any further than that kind of thing. But the way I build my control rigs, I've never needed to do that, so it will list all the joints. Return pull vector control. For a given IK handle or IK controller, it will return the return the pull vector, because obviously we have to be able to snap the pull vector in place in order to switch from FK to IK. This proc here will return the pull vector marker for the pull vector controller, and that's simply looking up through the message attributes that we created. And then this FK marker, return FK marker, again, it's going to do the same thing except for pull vectors. Instead of pull vectors, it's going to use the IK switch marker to do the same thing. And those are the low level procs. These are the little worker bees. We're going to go up higher. These are this is our middle management, if you want to think of it that way.